Hello, welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Today we're going to be taking a look at Kaniko, a tool for building container images in Kubernetes. Now, before we get started, there's just a little bit of housekeeping. First, if you're not already subscribed, rude, but you should subscribe now and click that bell. This helps other people find the content, plus you'll get notifications for each of the new episodes coming up. Also, if you're not watching live and you have questions or you want to make suggestions for new technologies to cover on Rawkode Live, then you can join the Discord. There's a few hundred people in there now talking about cloud native Kubernetes and everything in between. So come and say hello. And lastly, I want to thank Equinix Metal, my employer, for allowing me to do this. You can check out Equinix Metal using the code Rawkode. This will get you $200 of compute. That's anywhere from 50 hours to 400 hours, depending on the machine that you choose. So, have fun or use it wisely. That is up to you. Now, today, to introduce us to Kaniko, I am joined by Tejal Desai from the Google Container team. Hi there.
Hi, David. Thank you for having me.
No, the pleasure is all mine. I'm looking forward to playing with Kaniko today and showing it to the people that are watching. Do you want to just take a moment to tell us a little bit about yourself, and then we'll get started?
Yeah, sure. So my name is Tejal. I was born and raised in India. I came to United States for my master's a decade ago, maybe. And after completing my master's, I've been working as a software engineer. I've been working at Google since pretty much last 5 years, mostly in container developer experience and container tools. I'm currently the maintainer of Kaniko, and I'm actually working on another awesome container development tool, which is Scaffold. I manage Scaffold at Google now.
Awesome. I'm a big fan of Scaffold as well, actually. It's a really cool tool, and Kaniko. So I'm looking forward to showing both these tools off. I actually have someone from the Scaffold team joining me next week to do an episode there. So that'll be awesome too.
Yes.
All right. Do you want to just, will we start with a little bit of a brief introduction of just like what is Kaniko and what is it for?
Sure. So Kaniko was started at Google maybe around 3 years ago as a way to build images in your cluster securely. Before Kaniko, people used to actually install Docker inside their cluster. Docker inside the cluster is not a great idea. It has a lot of, security concerns because you expose the Docker socket. So anybody could tap in and, just take advantage of the Docker socket and end up, corrupting your Kubernetes cluster or, send a run malicious code or anything like that. So for that reason, Kaniko started as a starter project, one of the projects that, in Google, you end up giving to a new engineer. But we found out that it has a lot of potential. That was something that was missing in the market, and people adopted it and became one of the popular tools now. So Kaniko lets you help build container images inside the cluster without the need of Docker. So what it does is it spins up a container and runs all the commands in your Dockerfile. It'll run it on the operating system, on the container itself, and detect what changes a particular command run ended up doing to your file system, and would build image layers based on those changes, and then produce a Docker image.
Okay. I think I understand some of that. So let me try and repeat some of that back. So I understand that running Docker inside of Kubernetes is not a good idea because we have the Docker socket and that allows people to do bad things with their containers, particularly in the older days where Docker had to run as root. I know there's some changes and advancements there. But then Kaniko came along and tried to provide a secure way to do this. Now, so does Kaniko still launch containers for each of the layers, or is it doing something magic within the existing container? Like I don't think I understand exactly what's happening there.
That's a good point. So let's dig into the internals of Kaniko. So you actually spin up as someone who wants to build image, you would spin up a pod, which runs a Kaniko container image. Kaniko itself does not spin up any container images or any containers to build individual layers. What it does is on your container executes the commands in your Dockerfile. So if there is the first command of your Dockerfile is from, then it'll go and given that the Kaniko container has access to your image repository, will go pull the image, the base image, and then untar it and extract it. Then it'll take a snapshot of your file systems. Now we'll run the next command in your Dockerfile. If it is a meta command, which is just like setting work directory or setting user permissions, then it doesn't do anything much. It'll only update the image manifest and metadata in the image. But if it is a Docker run command, which actually ends up manipulating the file system and adding new files, generating new files, Kaniko will run that. It's as whatever user you've set it to run as, and then it'll take a snapshot of your file system now. So with the snapshotting mechanism, it can detect what were the changes that happened between your first command, Dockerfile command, and the next Dockerfile command. And then it'll pull up all those changes, create an image layer out of it.
Okay. So, in my naive understanding then, is it fair to say that Kaniko is like doing a chill root and with the layer file and then running a command? Is that in a really simple term? I'm sure there's more going on, but...
In the simple term, yes, it is actually executing the commands in your Dockerfile and figuring out what changed.
Okay, cool. That actually helps a lot with just the basic understanding of how it's putting this together. I think maybe it's important to note for the viewers at home then is that there's nothing particularly special about a container image, right? They're just literally what you said is a bunch of tarballs that happen to have some JSON manifest data that tell it ordering and semantics and metadata, and that's it. Like, there's nothing particularly special. Right, okay. Cool, awesome. Then I think what we'll do is we'll jump over to the screen share and we'll try and build a container image. I say try, I should have more confidence, shouldn't I? Like, we will build a container image. All right, so this is the Kaniko GitHub repository. It's available at github.com/Google Container Tools/Kaniko. There is lots of documentation. I noticed as I was kind of poking around earlier. I'm assuming we're just going to go to the tutorial to get started. Does that sound fair?
Let's do that.
All right. Okay, so the getting started tutorial, or are we scrolling down this page?
I think let's get to the getting started tutorial.
Okay, so prerequisites. Kubernetes cluster. Check. I have a Kubernetes cluster. I also have Docker for Mac if we need to fall back on it for whatever reason. I do have a Docker Hub account. If we need to get the token for that, I'll do that sneakily over here. So I think 2 ticks on the prereqs, which means we can just jump straight in and build a container image.
Yeah, before that, we need to actually mount your source code onto your Kubernetes clusters. So I think the several next configuration files that are there, the pod.yaml, the volume, and the volume claim helps you do that.
Okay, so let's see what this is. Let me just zoom in on that a little bit. So this is just a pod called Kaniko that runs the Kaniko executor. It's just looking for some volume. Yeah, so go for it.
The interesting part is from line 8 onwards, where we are actually mounting your secret, as well as we are also mounting storage, where you would end up mounting the source code that you want to build.
Okay. So if I'm using a remote Kubernetes cluster, is that a problem?
No, it shouldn't be.
All right. Okay. So you just want me to copy this and save it locally, right?
Yeah.
Yeah. Okay. And this is just going to be our pod.yaml. I did pop open code, so we can just do a new file. Save as pod.yaml. And we need the two other ones. So here is my volume. So just so that I understand, oh, this is the PBC. So that I understand. Is there a CLI element to Kaniko that I execute on my local machine?
So Kaniko cannot be executed in your local machine. It has a binary, but the Kaniko design is based on the fact that you're running it inside a container, and it ends up entering your root file system, manipulating your root file systems, and deleting certain things, and registering certain special directories. And if you run Kaniko on your local machine, we might end up deleting certain files, which is something that you would not want to do.
Yeah, that sounds like a terrible idea. Okay, so I do see that we're using host path here in the persistent volume. So if I'm working with a remote cluster, how do we get the data into that location?
That is a good question. I think this tutorial actually assumes that you are running in a remote cluster. Let me go back and check.
Oh no, okay, so it wants me to SSH into the cluster, I think, just to provide the build context. Okay, we can do that.
Yeah.
That's not a problem. Okay. And it wants me to create the secret. I'll do that when we get there then. So first things first is we just want to go on to one of the machines. Okay. I guess if I use Docker for Mac, that's not really a problem.
No. If you want to run Kaniko inside right now as a Docker container, it's just one Docker run command. It's not part of the tutorial, but it is on the README, and we could try that first and then switch to this flow.
And I think we can just use the Docker for Mac ships with a Kubernetes API that handles all the volume mounts for us. I reckon we just go with that and see what happens.
Okay.
So we'll stick with the tutorial. I'll just pop open Docker. I'll make sure I'm on the right context. And I'm just going to try it as it is. So if I just, that also means I won't have to set up the registry token secrets either. So, double win. So what we want here is, oh, I don't know the Mac paths. I really should know that. Let me get that. So I'll call this context. I think that's what the tutorial roughly said, and then I'll copy this. And that should just work. I'm saying that as a question and a statement at the same time, so you can tell how confident I am. But I reckon we'll be okay. And if not, we'll work around it. Okay, so this says, it says create Kaniko. I've got context, that's fine. It then wants me to create a very simple Dockerfile. That I can do. Command. No, forgotten how to Docker. Echo entry Docker. I'm doing well today. All right, save this as my context. Docker file. And I created a context there. There we go. That looks better. That's actually suggesting Ubuntu bash echo hello. I think we'll be okay with mine. If not, we can blame me for it breaking. Okay, now it wants a secret. Now, because we're using Docker for Mac, I think I can just sneakily log in over here. I always worry that when I type my password into one password, it's magically just going to show up somewhere because I'm on the wrong box, but I think I was okay.
It's not showing up.
It's just I think I've flashed a password twice on this show now, so wouldn't be the end of the world. Okay, so let's confirm my hypothesis before we move on. Oh, I'm on the wrong context. Oh, I'm not. Oh, I probably have this. See, when I said that things go wrong and it's always me, that was no word of a lie. Okay. Do we have... No. Okay, we'll see what happens. Okay, let's assume that I've got maybe everything working and it might work. Now, are we just moving straight down to the create resources in Kubernetes section, which is just to create, I guess, those 3 YAML files that we've saved locally inside of our Kubernetes cluster?
Yep.
Oh, I should really be in the right directory. Okay. Now I wish I'd given them better names too. Oh, it's 3 Fs, isn't it, when you do it? Oh. There. Okay. So, get pods. And I'll assume Kaniko was just pending because we're pulling the image and not because I've made a mistake.
No, it could be because there is something wrong going. So let's do...
Oh, okay. It's complaining about my volume claim.
Mm-hmm.
All right. I guess I'm debugging already. Okay. Dockerfile claim.
Local storage not found.
Oh, come on, Docker for Mac. Why are you being mean? Oh, it says bound now. Was it just slow? Yeah.
Oh, great.
Yeah, I wasn't worried. No, not at all. Yeah, container creating would mean we're pulling an image, hopefully. So we'll give that just a few seconds and we'll see what happens. And we'll see what the tutorial tells us to do next.
Mm-hmm.
So it's suggesting we just take a look at the Kaniko logs. Oh, so well, there's something I hadn't realized then. So by applying the pod.yaml, we have now actually triggered a build. Is that correct?
That is correct. So Kaniko executor is the entry point for the container image that you just created a container for, and it's going to start executing the build.
Okay, let's see if it's still pulling or if it maybe... Yeah, successfully assigned. Oh, the volume. Oh, the reg cred. All right, I was hoping Docker for Mac was just going to take care of that for me, but I should learn by now never to skip a step in the tutorial. All right, I will also do that in secret. And you said that that pushing to a container registry isn't our only option as well. There's a few other ways that we can work with the built image.
Correct. We can create a tar, and then skip pushing by using a flag, called no push.
And is that something that you see often, or is it pretty much standard just to push it straight to a registry of kind?
There are a few folks who requested that flag. I'm not sure what the use case was, but the standard use case is pushing.
Okay. So I have created the secret, the Docker server. I don't know if it said it in the docs. Is that just Docker? No, I have to use this. I was going to say, of course it says in the docs. Let me fix that. Edit secret. Right. Oh, it's all weird. All right, I need to just recreate it. That's what I get for just thinking I could type docker.io and get away with it. Okay, I've created a new secret. So I don't know if I'll need to. Should I maybe delete the pod, or do you think we can just give it a little bit of time and it'll work out what's going on?
Let's give it a little bit of time. I think it should be recovering. Maybe the scheduler will just delay the retrial. It's still saying not found.
The secret reg cred does exist now.
Yeah. Okay. 40 seconds ago.
Yeah, you're much more patient than I would have deleted this.
Let's just delete it. Start again.
Yeah, why not? Just applying a pod. So in theory, we should see it spin up pretty quickly because it has already pulled the image, and the secret should exist.
Yeah. I think also in the pod definition, was there a few things that we had to substitute? Yeah, here, the destination needs to be substituted with your username and repo, line number 11.
Aha, okay. So, Rawkode, Kaniko demo. Would that work just fine?
Yeah.
I don't think we need to change anything else. Yeah, it's even nicely commented for me. Again, just not paying enough attention. So, and this will all just work. This is the name of my secret. Okay, let's try that one more time then.
There it is. It is pulling the image.
Yeah, it looks much better. There we go. It's running and everything. Phew. I guess we expect, because this is just a pod executing a single task, it's either going to say complete and I've not messed anything else up.
Yeah.
Good. Or else it would have said error and I probably had a little tear, but we're okay. So this is now built. This
Correct. So,
Dockerfile.
Right. We could now look at the Kaniko pod logs to see what got built and what was the image pushed and if there were any issues in the build.
All info, which, I mean, I'm pretty confident that worked.
It should work. You should see an image. You should be able to pull it.
Oh yeah, I could just run it, right? Docker run rm rawkode Kaniko demo. And I'm assuming because I never specified or tag, is it using latest or is that something I should have specified?
Now it should push to latest.
I think it kind of worked.
Okay.
Except for I didn't get my actual echo hello.
Yeah, I was confused about that too.
So that could just, again, me not doing things very correctly. So why don't we make a change to our Dockerfile? So Alpine uses ash, -c is the same as bash, and then, echo. Okay, so I can just, I can't reapply this because we'll have an existing pod, is that right? So I'd probably just have to delete that anyway. Oh no, it doesn't seem to.
Oh,
I haven't changed anything. Yeah, I'll clean it up.
Oh yeah.
0, force, and apply again. And I'm assuming if we just watch that, we'll see it I can just watch the logs from now, right?
Yeah.
We see the Dockerfile is now pushing. Okay. Let's try again. Oh, Docker image pool. I don't know why my container's not talking to me, but I'm feeling slightly hurt because of it. Should
Yeah.
I think what I'll just copy this one. Maybe that would be a good idea.
Okay.
I'm not sure. Oh no, you know what? I am just being really silly today. We're not going to see the output if we don't assign a TTY. Maybe? No. Okay, clearly I just have no idea what I'm doing. Okay. Let's try one more time. I will have a container say hello to me. That's the last thing I do today. Logs. It's not started yet.
There.
It's still pretty quick considering it was pulling an Ubuntu image. That was a lot faster than I was actually expecting that to be. So let's just pull the latest tag. Yeah, it's a bit bigger now. I guess the Ubuntu image just must be available for some weird reason, I guess. And it said
There it is.
I don't know what's wrong with the Alpine one. I'm not going to dwell on it, but I'll bet I lose sleep over it later. Okay.
Cool.
So that's it. We built an image.
Yeah. So I think one of the mostly used feature of Kaniko is the caching feature. Kaniko caches images and only runs command if the command has changed. When I say caches images, it means it'll end up caching the intermediate layers based on your command, and then a few other things that we find out if the previous lines have changed, which could end up affecting the current Dockerfile command or not. And then based on that, we will either use the image from the layer cache if it's something that we think that nothing has changed. If things have changed, then we'll rebuild it. So a lot of folks, use that feature. We cache the copy command and the run command. Run command has the greatest advantage because that just means that if you're actually, installing things from, pip install or anything crazy with apt-get, then if we already know that a particular layer is cached, then we'll not run apt-get blah, 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 and, install. We'll just take it from the cache. So we could try that command with a more complex Dockerfile.
Yeah, so where is that cache part of either of these volume claims, or is that doing something else there? Like, where does that caching information live within the cluster?
That's a good question. We currently support remote caches only. So you can specify what your cache, where you would want your cache to live on the remote. If you do not specify it, we make a guess. It's just based on your destination and then /cache. That's where all the caches would be. There is an outstanding feature to support, caches, persistent caches, but we just haven't had time to actually go implement it.
Okay, yeah, that makes a lot of sense. So is it fair to kind of, is it like the cache from parameter where you can specify another image if I were using like the Docker CLI? Is that kind of what the remote cache is like with Kaniko?
So you have to specify it as a flag for the Kaniko executor. So if you look at the pod right now, here, like you have -- destination, there is a flag called cache destination probably, and then -- cache, which will turn on caching true. I might be wrong on the cache destination. Maybe you'll have to go to the README.
Oh yeah, let's see. You're right. Let's get a slightly more advanced Dockerfile, and we'll try out the caching. Let's see, is that going to show up here in this tutorial, or should we need to? No, okay.
No, we'll have to go to.
Okay. So if I just search for cache, we get all of these flags. Okay, so we've added cache true. I'm assuming cache repo or cache dir.
So again, cache dir and cache repo are optional. If it's not provided, then we just make a best guess based on your image repository.
Right. Okay. So I don't even need this parameter then. I can just do -- cache, and it's going to work out the best way to do this probably. Okay. So if I grab my Dockerfile, and then it probably helps that it moves to Ubuntu now, so we can do something in which we would consider relatively heavy, which would be like an apt install vim. And I'll just make it. In fact, we'll bring this one in next. Let's run this first one first. Does that make sense? And then we'll add in more apt commands. And I guess what you're saying is if we view the logs of the Kaniko build executor, we'll just see it saying skipping a step or using the cache or something similar.
Yep.
Okay. Let's apply that. We'll run git pods. And not quite yet. There we go. Well, it looks like, did it use a cache there?
No, in this case it did not, because this is the first time you're building. So we only have a cache per image. So if this is not a global cache, it's just for your repository, right?
Yeah, so it just said it was checking for a cache, but it didn't find one. We can now see it running the thing. Oh, I didn't specify the yes flag. So let me delete and apply one more time. So I'm curious then, are there any, based on the way that the executor works, where it's fetching the image, extracting it, doing some sort of chroot in a command run, does that mean that if I want to build, say, an ARM image, I have to use an ARM Kubernetes node to do that?
Yes, currently we do not support cross-platform builds. Again, a lot of people ask for it. We also have multi-arch Kaniko images. So right now, if you look at our release page, we end up publishing Kaniko images for ARM and AMD 64, and then maybe one more that I'm missing. But yeah, you basically need to run on a cluster of that target type. If you are building Go images, then we have a way to specify the arcs, like custom platform, and then you would have to write a Dockerfile where you set the Go OS and Go Arch to the right arc in operating systems, and do a cross-platform build which is supported by Go.
Okay, I think we had a small problem there, and I don't think Docker Hub liked us trying to push to /cache.
Ooh, okay.
I don't know if that's expected, but I see the yellow warns. I'm kind of like, oh, maybe not, and it says failed to push. So.
Oh, is it because you already have something over there, or it shouldn't happen? Never seen this.
Well, I don't think Docker supports the /username /repo /something else. At least I've never seen that before.
Oh, okay. Then you could use the destination parameter, the cache dir, or let's see.
Okay, so I can set a flag to specify a local directory for cache for base images.
So this cache dir is just for caching base images. So a lot of people, especially in CI/CD case, your base image is the same, right? You don't have to pull it every single time. So we also provide, we could get into that later, but we also provide a way to load your base images. And then instead of pulling it during your build, we'll just reference it from that destination directory cache dir. What we need for caching is the cache repo flag.
Oh, right. Okay, so we can actually dash cache. We can just override where it's going to store the cache for that. Okay.
Right.
Oh, let me do that
See.
then. I could just say Rawkode Kaniko demo cache.
Yeah.
Okay, cool. That makes sense. So let's delete our old pod. Now I'm going to assume just with the delete pod, create pod, delete pod, is it Kaniko a tool that you expect people to run in a local dev environment, or is it targeted more at machine automated CI/CD kind of processes?
Mostly for it's used mostly in GitHub workflows and Tekton CD pipeline for CI/CD cases. For local, usually Docker build is fastest. Enterprise users who don't allow Docker to be built on developer machines can also use Kaniko.
Yeah, I can see how this would work really well with Tekton, actually, just with its ability to kind of create those pods as the workflows or the jobs come in and then build those images. Right. So I definitely picked something that was time intensive to cache because it's a bit longer than I expected it to be. Yeah,
there it is.
Pushing it now.
Perfect.
Yeah, it seems a lot happier this time. Maybe. I guess my upload is not as fast as my download speed.
Yeah.
There we go.
I think you're building a big image.
Yeah, I'm really regretting my decision to decide to install Vim into this. However, I feel like we're committed now. So
we could install something light next time and
yeah.
make sure that it's not cached.
All right. So does that mean if I delete our pod and I just create that as is it's just going to use the cache and not do anything? Is that kind of what we would expect to see?
Yes, that should be what that should happen. Let's see if it happens or not.
Should is my favorite word on this show, that's for sure. Found cache there. There we go.
So yeah, this was much faster than our previous run.
All right, so we can delete that. We could continue to iterate on our Dockerfile, knowing that as long as we don't modify these cached layers and only add stuff to the bottom, we should always be able to leverage that cache for faster builds. And just the caching is based on, is this just like you just create a SHA-SUM or something of each of these instructions? I think you said earlier.
Right. Internally, we do create like a SHA-SUM of what the instruction is, and it's also keyed on the commands above, because sometimes a previous run could end up changing the the consequences for the next following run up. So if the previous cache of previous command also changes, we take that into account by keying the hash keys for commands seen so far.
Awesome. I think that's all very cool. Now that I can do this safely inside of my Kubernetes cluster without resorting to any privileged containers or any Docker sockets or anything like that. Just have something that I know is secure and safe. Is there any other features of Kaniko you'd like us to quickly take a look at?
Sure. So we could go to the README. So like I said, Kaniko ends up taking a snapshot before the command run, after the command run to figure out like what file changed. The default snapshotting strategy, I think if you could go at the end of the README, we explain a little bit about what are the snapshotting strategies in the snapshot mode. There is a full snapshot, which actually ends up also hashing the file contents of all the files, which could be time consuming. So we have 3 snapshot strategies. This is something that we ended up doing, especially for projects like if you're building if you're running NPS or node install or apt, you end up generating a lot of files, right? And then we are actually hashing the contents of these 1,000 files. So snapshot full wasn't very, fast enough for users. Like it would end up snapshotting for maybe 14 or 15 minutes. So we ended up, introducing another snapshot mode, which is redo, which ends up actually only hashing the metadata about the file, like the time, the size it was size and time it was created or modified, owners, and blah blah blah. So it has proved to be 50% faster.
Nice.
And then there is another one which is just time based on M time, but again there are certain limitations related to M time because time can move forward and time can jump around. So those are a few things that you could, if you see like your build is slower, I would suggest try these snapshot modes.
Cool. So is the snapshot filled? Is the default is this here. Okay.
Yeah, it is a default. It works for most of the cases, but only for Node.js projects, we've seen like people have complained about the snapshotting time.
I guess that's because of that huge node modules directory that a lot of these Node.js projects have.
Correct. Yeah.
Yeah. I think that's just a general problem I hear when I speak to people at conferences when that was a thing, is that working with, it was always kind of interpreted languages, never compiled, and the amount of files and vendor stuff that they have going on was always kind of difficult in Docker build steps. So yeah, I understand that.
Yeah.
Is there anything else you want to cover?
Sure. I think one thing, we support a bunch of registries. We also support something called as reproducible flag, which is a lot of people do end up using it in production if they would want to make sure that the image is reproducible. So we end up stripping the timestamps of the built images, so you could exactly compare 2 images and understand if there are any file changes or not. So I think Google, we have a base image repository project where we end up publishing images that you could use with just like minimal things, and we use the reproducible flag over there to create those images, so people can end up understanding what were the differences, and it's always reproducible. The time doesn't change for the image build. There's a single snapshot. You could create like one snapshot of the entire Docker file instead of like having those intermediate image layers. There are a bunch of flags that you could just go and see. But the interesting thing is about the cache warmer. So we have, if you go to our release page, it's a little bit out here. So we have a bunch of images available. There is executor, which is what we're trying right now. There is a debug image, which only has the busy box installed in it. So you get the shell. So if you want to debug your Dockerfile or debug your builds, you might end up using the debug image. So you could run all the shell commands available. There is Slim, which is something that was requested with Tecton. I think with the executor image, we bundle a bunch of binaries. Like we support different types of context, not just local file, but even like you can pull a Git context, Azure, GCS, and we end up like bundling a lot of binaries for those. For Tecton, usually like the code is checked out and everything needed is already present. So Slim works for them because all you need is the Kaniko binary. And then we have, if you go down, actually, warmer image. This is the cache warmer. It's not on the release page, but the cache warmer could be used to download your base images. So when you are and mount them, store them in volume storage for your Kubernetes cluster, and then when performing build, all the base images would be extracted from that volume mount and wouldn't be pulled. So you could again make your CI build faster because generally your base images remain same. You would upgrade them once in a while. So you would first, whenever you want to upgrade your base image, so suppose you were on Go 10 and now you're increasing the version, then you run the cache warmer executor once to download your new base images in a cache directory. And then from then on, you just use the executor to reference those base images.
Yeah, that makes sense as well. So I guess this is something that if I want to use my Kubernetes cluster to be building all of my container images in a CI step, like because this is all like the Kaniko executor is confined to a single pod and it is working on its own and it's pushing to remote caching and stuff, like I could scale these just horizontally by however many builds I need to run at any one point in time.
Yes, you can. If you have a lot of nodes, there shouldn't be a scheduling problem. You could run as many as you want in parallel.
And is Tecton the approach that you encourage people to use to use Kaniko, or are you using it just as straight up Kaniko? Like, is there a decision to be made there, and how do I make that decision?
So Tecton, I think, is more of an orchestrator. So you could end up designing your pipeline for the build step in your Tecton pipeline. Kaniko is recommended, or one of the builders that you could use. Kaniko, GCB, Google Cloud Build, also supports Kaniko. So you could run a Kaniko build on GCB and take advantage of all the caching. I know a lot of users, Kaniko users, use GitLab workflow. I haven't looked into it personally, but there is a tutorial dedicated to Kaniko on the GitLabs. People fix a bunch of issues related to that in Kaniko.
Yeah, as someone who has used GitLab CI an awful lot over the last however many years, getting the Docker builds to work on it was always an absolute pain, and looking for something like this would have made my life a lot easier. Definitely, for sure. Okay, I think I've got like one more question, and then if there's anything else you want to cover, we'll do that. You mentioned during our chat just a little bit ago that you said a Git context for the build. Correct. I can use a Git repository for the build context. So I guess that would remove that persistent volume claim mounty thing. Is that something that's just supported in vanilla Kaniko? There's nothing else I need to do there?
Well, you need to provide your Git credentials so that we could check out your Git repository. But if you go a little bit up, in the README, there is a section. If you go to the top of the README, you would see the link for Kaniko build contexts. And these are the contexts that we end up supporting: GCS, S3, Azure. Because Kaniko is open source, a lot of developers who are using Amazon, AWS, or Azure, Microsoft, they have ended up contributing these features to Kaniko.
Okay, so that means, let me just, okay, so I can just drop a get URL into new,
Your pot.
this, yeah, that's it, right?
Yeah.
Okay.
Yeah.
Oh, awesome. Yeah, okay, that actually helps just understand how I would actually use this, I think, a bit more. But I can provide a secret for private Git repositories. I'm assuming for open source repositories, I don't hopefully maybe need to provide anything there. I could just drop in my Git URL and say build this, and then it would just go away, work, and I'd be quite happy. Okay.
Yeah.
That makes a lot of sense. Cool. We covered quite a lot there. Is there anything else you want to cover before I let you get back to your day?
No, nothing that I can think of.
No, that's quite all right. I think what we've done is we've had a really good look at Kaniko, how it works. I love the simplicity of it, the way that it works, and it's the caching thing. I think is really cool, and having the flexibility to tweak those cache parameters and how I want them to work to speed up build times is particularly useful as well. So let me just move my screen. Awesome. Well, thank you very much for joining me today. It was nice to kind of be guided through Kaniko, show people how to get involved, how to get started. I'm assuming, as it's an open source project, that people can come to the repository, find some simple issues, help contribute, and be a part of the community.
Yeah. Yeah. I am the maintainer. I end up like releasing every month. So look for maybe today, third week of every month, I go through pull requests. I help people get those over the finish line if needed. And again, like we have issues triaged and, with labels help wanted, like the general open source logistics. And then, anyone can pick any issue they want and add features to Kaniko.
Awesome. All right. Well, people should definitely get involved, check that out, have a play, and let us know how you get on. Tejal, thank you for joining me today. I hope you have a great rest of your day, and I will speak to you again soon.
Yep. Thank you so much for having me.
Thanks,
Bye, David.